Hello and welcome to my HVAC system analysis. My name is Martin Ramirez and this is ECT 340 Lab 7. In our HVAC system, we have three external devices. We have one motor and three LEDs to indicate the operation of the HVAC system. The system process is as follows, as we can see here on this loop of the HVAC system. We begin on the star, the temperature sensor. The sensor outputs a voltage and it goes to the analog to digital converter, where it outputs a digital equivalent, which is then passed to the microcontroller to be processed. The microcontroller activates the current driver and activates or deactivates the motor, as well as activates or deactivates LEDs depending on the temperature range sensed by the temperature sensor. Let's look deeper into each process. We have the temperature sensor, also called the thermistor, which is the LM35. The temperature sensor converts temperature in degrees Celsius to a linear rate of change in millivolts per degree Celsius. Next, we have the analog to digital converter. The analog to digital converter uses an output voltage of the thermistor and outputs a digital equivalent in binary. This equivalent moves to the microcontroller. Microcontroller is inside of the Arduino 328. We program the microcontroller with the C++ code or C code. I will show a few slides with code in the following section. Next, we move on to the current driver, which is the L293D. We only use one channel. We're only spinning our motor in one direction. The L293D current driver is activated to supply a high current to the low DC motor. It is activated or deactivated depending on which temperature range we are in. The LEDs are activated or deactivated depending as well on what temperature range we are in. Let's look at that closely. Since we have three devices that we are using in our system, let's talk a little bit about each of them. First, we have the LM35 thermistor, which has a temperature junction ranging from absolute 0 to 150 degrees Celsius. Of course, nothing can really get to absolute 0. We have the supply voltage ranging from negative 0.2 volts to positive 35 volts. Our rate of change is in millivolts per millivolts per degree Celsius, and it is in 10 millivolts per degree Celsius at nominal ambient temperatures. Our Vout will be at 10 millivolts divided by 1 degree Celsius multiplied by the degree Celsius measured. We also have the analog to digital converter, which is the component ADC 128S102. The voltage revolution, which is the step size, is given by the voltage reference, as we can see, is 5 volts in VA, and divided by 2 to the power n, where n is the number of pins. If we look at the data sheet, it says on the data sheet that we use 12 pins, so it would be 2 to the 12, which is 4096. Our Dout is Vn divided by V resolution, where Vn is the Vout of LM35. Our Dout is sent into the microcontroller for processing in a serial fashion. The other component we are using is the current driver, which is the L293D. The output current of the current driver is 1 ampere per channel. Only one channel is enabled for this system and can drive up to 2 motors bidirectionally, although in this system we are only driving the motor in one direction. The max input supply voltage is 36 volts and the max input voltage is at 7 volts. We can see here our HVAC system. On the top right hand corner we have the temperature sensor LM35, and beside it to the left we have the analog to digital converter. Beside that to the left again we have our virtual terminal where we will be outputting the information such as the temperature, the room being hot or cold or nominal, the AC engaged or disengaged, and the fan engaged or disengaged, as well as the LEDs engaged or disengaged. Below the virtual terminal we have our current driver, which is the L293D, and as you can see, I06 is connected to in1 and I07 to enable, which is only one channel. Our supply voltage is 12 volts and the motor is to the right of it, connected to pin 3. Beside that device are the 3 LEDs that indicate the operation of the HVAC system. In this slide I show you the code used to program the microcontroller in the Arduino kit. We are using serial peripheral interface to transfer data from the ADC to the microcontroller, so we need to include the serial peripheral interface header file. We're defining the reference voltage as 5 volts, and we are initializing the LEDs to their respective pins, as well as the fan to its pin and the enable bit for the fan. Inside of the setup, we use pin mode function to assign a pin to its corresponding signal direction. Slave select, the 3 LEDs, the fan enable pin and the fan driver pin are all set to output signals. This is where I use the constants which I initialized in the beginning of the program. We can see here that pin mode parentheses GLED comma output parentheses sets pin 3 as an output pin. This is done for each LED and the fan and the enable bit of the fan. We also have information that is displayed onto the virtual terminal, such as channel, the reading of the temperature sensor, the voltage, and the temperature. The step size is calculated and multiplied by the ADC read value provided by the ADC, which is then displayed on the virtual terminal as well. The value read is converted into temperature and also displayed in the virtual terminal. Next, we have the section of code where the temperature is read in the iteration blocks and checked for truth. In the first block of the if iteration, we have if the temperature is below 20 degrees Celsius, the room is too cold. The temperature sensor sends a voltage to the microcontroller that enables it to engage the heater and the fan. The corresponding LEDs will activate, and the fan driver enable bit will activate. The case is the same with other temperature ranges, each with individual effects. In the case that we are at nominal ambient temperature, the fan is disengaged, the heater is disengaged, and the AC is disengaged. So the HVAC is set to idle and waits for there to be a temperature below 20 degrees Celsius or above 30 degrees Celsius. In this slide I show you the HVAC system. Let's pay attention to the LEDs, the motor, and the virtual terminal. On the first image, beginning from the left, we see that channel 0 equals 0.17 volts. temperature equals 17 degrees Celsius. The thermistor is outputting a 0.17 voltage and is input to ADC. The ADC converts this into a digital format and is passed serially to the microcontroller in the Arduino kit. Once the Arduino microprocessor processes the information given, we see that the 17 degrees Celsius enables the green light, which means that the HVAC is on. It enables the red light, which means that the heater must be activated because the room is much too cold. It is below 20 degrees Celsius. And the fan must be turned on. So this means that the L293D current driver is enabled. The IO6 is also enabled for the first channel in the L293D, which enables the motor. You can see that we are at plus 329. For the second image, we can see that in the virtual terminal, channel 0 equals 0.24 volts. The temperature is 24 degrees Celsius. This means we are at nominal ambient temperature. The room is comfortable. So, the LEDs are all off, meaning that the HVAC system is not operating. It is on idle state. The motor has slowed down and is now at 0. This means that it is off. If we increase the temperature, we move into the next image, the third image on the right. On the virtual terminal, we can see that the channel 0 is at 32 degrees Celsius at a temperature of, channel 0 is at 0.32 volts with a temperature of 32 degrees Celsius. The room is getting hot. Thus, the AC engaged. We can see that it is engaged by the blue LED being on. And once again, the green LED is activated, meaning that the HVAC system is operating. The L293 is enabled once again, and the motor is functioning at plus 475. This concludes my presentation. Thank you for watching.